Hello and welcome to the 60-second video in the series Programming a Chess Engine in JavaScript. So in this video we're going to reach the stage where we can actually search where the engine can search and we can play a game against the engine. So first thing I want to do is in search.js, I was in the wrong file there. We need to think about how this is going to run. The first thing I've done is I've taken out our sort of hack in here to fix the depth of the search, and I've now put it actually to search up to the controller.depth. Now we won't actually have the capability in this version of the GUI, and indeed the official version on the website doesn't have it yet either. But we have depth in here because in the future you might want to put a drop-down list in there also to set the search depth. At the moment I only have seconds of thinking time. So we want something in here that when the search loop is finished, that we can update the stats on the DOM. You remember that we have here these spans here which tell us the move, the score, the nodes, and the time and things like that. So we want to be able to update these DOM items here. So to do this we're going to write a new function, and I'm going to try and get through this all as quick as possible because it's not very difficult, as you can imagine, updating the DOM. So as quickly as possible I'm going to go through this, maybe with a copy and paste as well. So we take in, well, first of all we need a function name, so we'll call it update DOM stats, and then we'll take in our score for the DOM, and we'll also take in the depth that we managed to get to inside our search. And the next thing we need to do, well, the only thing that's slightly complicated here really is the score text. So the score text, the score itself is, remember, in center pawns at the moment, so a score plus 100 is a pawn, but it's normal to show a pawn as 1.00, so we actually have to show it divided by 2, and we'll do it also to 2 decimal places, so like so, and we simply have to take our DOM score then divided by 100. Okay, and the other thing we can do that's rather nice is to detect a mate. So if we say math.abs of our DOM score, so always turning negative numbers to plus, is greater than our mate score minus our max depth, that means we have found a mate, and in which case we'll change the text that we're writing actually for our score text. So now what we'll say is we'll say that our score text is now equal to score plus something else. I'm probably not doing this the best way, and we'll say score is mate in, and now we just want to find how many moves we've actually got here. So we say mate minus math, I think, yeah, mate minus math absolute of the DOM score, and then we can put moves on the end of there. I'll just put these two in brackets like this as well, and then I can just say moves, so at least the user thinks the engine is behaving relatively intelligently. And the only other thing then to do is to actually set the other DOM items. The first one is the only one I'll paste on its own. It's the ordering out, which is using simply the ordering that we've used up here, and the rest of them are completely self-explanatory into how they work. So I'll just drop them here, but we're simply setting the text to the depth, to the score text, the number of nodes from the search controller, and of course the one thing that I have forgotten here, I do believe we also have a best out as well. Yes, so let's put the best out in here as well. So we'll say best out like this, and we'll set this to move, or best move. And this is search controller.best, isn't it? Yep, search controller.best. But of course we'll need to do a print move like this on this so that we can actually get the text out like this. Okay, so that's the best move, the DOM stats updated, and the last thing to do is to call this function here with the DOM stats update, and we'll call that then with the best score and the current depth when we broke out of the loop. So that's that part then set up now for the search. And the next part that we need to do is actually set the engine searching. So we need to go into GUI and have a look at how we're going to do this. And you'll be glad to know it's pretty simple. First of all, we're going to put in a pre-search function. And this will be called whenever the user's made a move, after we've checked the status of the game. This is effectively does what it says on the tin. All it's going to do is say that if the game isn't over, then set the search controller thinking. So we'll say that if our game controller dot game over is equal to bool dot false, and this is why this is called always after the check state of game, or the check result is called after the user has moved, and this pre-search will also be called in the case of pressing the move now button as well. So we'll say if the game isn't in a game over state, then we'll set the search controller dot thinking equal to bool dot true. Now, one thing I have to say is thinking doesn't actually really, in this series, this whole series, find any use in the GUI. And in fact, I don't think either the player side and engine side of the game controller object either find a use in this series. But the reason they're in is whilst I was writing it originally, things kept popping into my head that I might want to do with the GUI at a later date, and therefore some of these variables are set even though they go unused. So sorry about that, but it's sort of just things I had in my mind for the way things might work in the future. Now, this pre-search is called after the user has made a move. The only problem is we need to do a little bit of a hack here, because if we let now the engine start searching, it's searching on the main thread, and it's going to stay that way because multi-threading in JavaScript is a nightmare with web workers, certainly for this series. And we need to give it a little bit of time to manage to update the DOM before it actually starts searching. Otherwise, you won't see your piece that you've moved on the board. So I'm going to put a little hack in here, and I'm actually going to use the set timeout function from JavaScript, where I can actually call then a function after a certain amount of time. So just make some brackets here, and then I'm going to put the code that's going to get called. It's going to be a function we haven't written yet called start search. You'll see in a moment how that function works, and then you can just put a comma and say I want that to fire after 200 milliseconds delay, and that gives enough time for the piece to be redrawn in the correct place on the board before we actually start searching. So next thing to do is to write, and don't worry, I haven't forgotten about the start search function. Next thing to do is to write is the code for the click on the move now or button, which I think is called a search button if I'm not mistaken. Where is it? Here it is. Yeah, search button. So we've got the search button here like so, and just want to type click and then like this, and then we'll have function, and here it's simply going to say okay, the game controller dot player side. This button is used when you say to the engine, doesn't matter who last made a move, I want you to start thinking for the current side. So that means we'll set the player side to the opposing side. And like I said, this doesn't have much functionality at the moment in the engine, but in the GUI, but in future editions it might. And then once we've done this, we'll then call our pre-search that we've just written above to set the engine then searching. So the last thing it needs to be doing now is actually to write the start search function. So just copy that name there and type function start search. So the first thing to do is we're going to set the depth for the search controller, which in the case of our tutorial series will always be max depth because we don't have anything to choose at the moment in the GUI for the depth. You can obviously very quickly add in your own drop-down list to choose it. So we've got max depth, and what we want now is to set var t to say what the time is now. So using the good old jQuery function now we can get in milliseconds a time, and then we'll get the thinking time that the user chose, and this is from our drop down list, which is called, where are you, think time choice. So we can take the value from that by using jQuery selector again and the hash for the ID, and then we can take the value, I think using the val function like so, or VLA if you're so inclined. So this will now store the 1, 2 or whatever that we've chosen from the drop down list which means that we need to set the thinking time on the search controller to our TT, but we'll set it to parse int of TT first of all, multiplied by 1000, because the times we get back from the now are in milliseconds, so we need this time also in milliseconds, and this is obviously search controller.time. And now that we've done that, we can actually call in the search.js the search position. Inside search.js, however, there has been a glaring error sitting there ever since in the early days we wrote this checkup function here. And I had a double equals inside here for the search controller.stop. Obviously it should be a single equals, so sorry about that. And one last thing we need to do now before we finish is we now need to actually make the move that the search controller returned. So when it comes to here, it will now have returned from its search position, so we'll do search controller.best to make that move, and that then will make that move on the internal board. And obviously then we need to go to move GUI piece of search controller.best as well to then move that piece on the GUI itself. And last but not least, we need to now call check and set to see whether the game is actually in a game over state or not, so that if you then clicked move now and it was a mate or something, the engine wouldn't start to think again. So all being well, and have I dropped pre-search? I just need to check in the right place. It is here, and I've forgotten whether I've dropped it in the make user move or not, so that we actually make the move. No, I haven't, so pre-search in there. So all being well now, the engine should actually, assuming not too many typing errors, search. So I'll refresh the browser, I'll choose 2 seconds thinking time, and let's see what happens. I'll click on E2, make E4, and now you see the engine is thinking. It's got to depth 6, and its reply after 2 seconds was E7, E5. It says depth 7 here. That'll be because, of course, with current depth we'll be on for the next loop before we broke out, so I have to correct that. 335,000 nodes, 85% ordering, and 2 seconds thinking. So let's just make one more. You see the engine's thinking again. And there we are, it's played the Petrov defense. So that's it really. We're not for the whole series, we've still got some more fine tuning to be done, but the engine is actually playing and thinking and trying to play the game and playing the 4 knights. I'm just going to click the move now to see if it actually does think, and indeed it is thinking, and it's played D2, D3, and I click move now again, and it's thinking again, and it's played D7, D6. Good, so it's actually now in a state where you can play against the engine, and let's just do a little test. We'll take a little bit more time, but you can stop the video now if you like. Let's set this mate position, and let's set the engine actually thinking for its 2 seconds, and seeing if it plays to mate here. And here you can see game over white mates, and it also played into the mate. Good, so that's it then for this video. In the next video, like I said, we'll start cleaning things up. We'll look at implementing this take move function and the new game button here, which I've just clicked and notice it's not done anything at all. So thanks very much for listening, and comments, questions, criticisms welcome as always on YouTube.